Hello, this is Ed Chapman, and this video cast is going to wrap up our discussion of Part B of our unit on ecology, and we're going to look at energy, biomass, and number pyramids, which are connected to food webs. Trophic pyramids are one way of showing the relative biomass of each level of a food web. Now, to understand this, we've got to make sure everybody understands what this word means, biomass. Bio refers to the living part of mass on Earth. And of course, mass is the weight. You can think of mass for this instance here as the weight of living material. So anything that is alive or once was alive is biomass. And biomass is kind of synonymous to organic material. So dead leaves, dead bodies, bones, stuff like that laying around is all considered biomass. And you can represent a food web, which we looked at in an earlier video cast, as a pyramid-shaped diagram. And you always put at the biggest part of the pyramid at the bottom, okay, the producer level. So this is where you would put all the different plants in an ecosystem that are feeding into or providing energy for the next level up. And the next level up are going to be the herbivores, things that are eating the plants. So for example, in this illustration, they have some rats here, which are largely herbivores. And then the next step up is fed by the energy below it. So the rats are food for a secondary consumer or a carnivore like a snake. And then you may have levels above that. So the energy is flowing up to the top level or the apex of the pyramid. And these would, in this case, would be the tertiary consumers or some more carnivores. So you've got the producers, the primary consumers, the secondary consumers, and the tertiary consumers in this particular trophic level pyramid. And what you should notice is the classic pyramid shape is used because the biomass is decreasing as you go up. So you start with the most biomass at the bottom, and by the time you get to the top, it gets very, very small. Now, if we actually drew this to scale, it would look more like something like this. Here we have the producer level, and then a very small primary consumer level, and then an even smaller secondary consumer level. So the decrease in biomass is actually even much more dramatic than this diagram shows if we actually measured it. Now, this is controlled by something called the 10% rule, which means that each time you move energy, food energy, from one level up, okay, only about 10% of that energy gets transferred to the biomass of the next level. 90% of that energy is lost as waste. Okay, it's leftover dead stuff, which may go on to decomposers. Okay, it may stay in the ground and become fossil fuel. It may just lay around. Okay, it can just be dead stuff. Okay, so the point is the pyramid or the energy transfer is very inefficient. Only about 10% of the biomass gets transferred up. Now, based on the 10% rule, can you explain how a ton of corn, which is 2,000 pounds, can feed more vegetarians than carnivores? Okay, can you do that? Okay, always remember that energy flows through ecosystems, but it's never recycled. You never get a loop, okay? So the energy starts out coming from the sun for the most part. It goes to producers. Then it goes into food chains, food webs, to all the different consumers, including decomposers. And a lot of the energy, as it moves through the food chain, is lost as heat. Okay, so eventually, all this energy becomes heat, okay? And the heat radiates from the earth back out into space, warming up the atmosphere as it does this, maybe warming up the soil, warming up you, but the energy leaks back out into space and is constantly being lost. You never have this heat energy going back around and re-entering the food chains and food webs. It's a one-way flow. It never recycles. Nutrients recycle, and we're going to talk about that later.